Welcome to the IMC YouTube channel. Maharashtra SET exam 2021. Question with detailed explanatory answer. Paper 2. Chemical Science. Part 1. Question number 1. The magnetic moment of potassium salt of FeCN6 3-. The magnetic moment is 2.3 mu B. Choose the correct statement of the following. In this complex, this Fe is the oxidation state is Fe3+. Is 6 - 3. So it's a Fe3+ is a low spin complex, which gives T2G. Fe3+ contains 3D5. This is Eg. Hence it has one unpaired electron. Here the T2G is unsymmetrical. And which gives a orbital contribution, and hence here answer it is spin only value as one unpaired electron. It's not a spin only value. The spin only value between 1 and 2 unpaired electron is also wrong. The increase in magnetic moment because of ferromagnetic coupling, it's also wrong. The increase in magnetic moment because of spin orbit coupling. Here listen, for one electron, one unpaired electron, the magnetic moment is 1.73. Here you see the magnetic moment given is 2.3. Hence the magnetic moment has been increased due to orbital contribution, that is the unsymmetrical nature of T2G, and hence answer D is correct. The increase in magnetic moment is because of spin orbit coupling. Question number 2. According to Wade's rule, the structure of B10C2H12, B10H12, SET twice are respectively. Here first you will take the first compound B10C2H12. Here this C can be written as pH, which gives B10. This is BH2H12, which gives B12H14, or this can also be written as B12H12 2-. It's a closo. It's a closo-borane which shows 4n plus 2 is a closo-borane, 4n plus 4 is a nido-borane. According to Mingo's-Wade's rule, so 4n plus 6 is a arachino-borane, 4n plus 8 means is a hypo, where n is the number of boron atom. Here it's a closo-borane, 4n plus 2. And let us consider the second one, B10H12 SET twice. Here this SET this donates 2 electron, and here twice means there are totally it donates 4 electron. Hence this can also be written as B10H 12 plus 4 is a 16, or B10 H10 6 minus, which shows arachino is an arachinoborane. Hence the given compound is, what they are asking is nido and closo. No, this is not closo and nido. No, closo and arachino. Option C is correct. This compound is obtained by B10 H14 ET2, which gives B10 H12 SET twice. Here B10 H14 is a nidoborane, and here it is an arachinoborane. So nidoborane is converted into arachinoborane. Hence option C is correct. Question number 3. The geometry of IF7 minus. Here the question is wrong. IF7 minus does not exist. Here it is IF7. For IF7, you see, for IF7 is a sp3 D3 hybridization with a pentagonal bipyramidal structure. Here this I source pentagonal bipyramidal structure. Hence option D is correct. Question number 4. A complex that possesses a D5 ground state term symbol for the metal ion. Here, let us take this metal ion Mn3 plus. Where the unpaired electron is for Mn3 plus, it is due to its strong ligand is 3d4, all electrons were paired and n equal to 0. There is no unpaired electron. In FeCN6 4 minus, here also is Fe2 plus, which shows 3d6, all electrons are paired, n equal to 0. Here it is Cr2 plus, which contains 3d4. Due to weak ligand, here it has 4 unpaired electrons. Here it's a cobalt 2 plus, which is 3d7, which has 3 unpaired electrons. For ground state term symbol, here they have given D5. For D5, the spin multiplicity which has 2s plus 1, and given 2s plus 1 is equal to 5. So S is equal to 2. S is equal to 2 means of plus of plus of plus of, which should contain 4 unpaired electrons. Here 4 unpaired electron is present in this complex. Hence answer B is correct. Question number 5. The magnetic moment of the complex MnCS6 4 minus is 6.06 μm. Its electronic configuration is here. In this complex, the manganese is Mn2 plus. NCS is an weak ligand. This was not a strong ligand, it's an weak ligand. So for Mn2 plus, for a weak ligand, it's a 3d5 configuration, T2G, Eg, all are unpaired electron. There are 5 unpaired electrons. Hence it is T2G3 Eg2. Option here. T2G5 means it's for strong ligand. It's for strong ligand field, but it is a weak ligand field. Hence option A will be wrong. Option B is correct. T2G there will be 3 electron, Eg there will be 2 electron. And here in C, T23 E2, this is for tetrahedral. This is for tetrahedral, but here they are given is a octahedral complex. This is an octahedral complex. The given is an octahedral complex, hence option C is wrong. T2G2 Eg3, no, it's just a reverse to this configuration, hence D is also wrong. B is the correct answer. Question number 6. Mulliken symbol for possible G term in octahedral ligand field is. Here the Mulliken symbol for S it is 1, is A1G. For P is 3, is T1G. For D is 5, is T2G and Eg. For F it is 7, where you will have A2G, T2G and T1G. For G orbital you will have 9, which is A1G, T1G, T2G and Eg. For H it is 11. For I it is 13. Here they are asking for G term. For G term you have A1, A1G, T1G, T2G and Eg. Here option C is correct. Here A1G is for S term. S term is A1G. T2G and Eg is for D term. So this is wrong. This is wrong. And A2G, T1G and T2G is for F term. Is also wrong because they are asking G term. Question number 7. For a metal-olefin complex, a 2 metal-olefin complex has been given. What happens to the carbon-carbon bond length? They are asking. Let us see. Let us take the complex. Here is a metal olefin. Platinum is a metal which is complexed with the CCF4, and you will take the second complex PT is complexed with the ethylene molecule HH, ethylene molecule. Now what happens to the bond length? They are asking. Here you see the fluorine. The 4 fluorine atom is an electron withdrawing group. So electron withdrawing group. As a result, this is a electron withdrawing group which withdraws the electron from platinum, which shows more p pi d pi back bonding. As a result, what happens? It forms here it gives like this. You will get the structure like this, where this carbon-carbon double bond becomes carbon-carbon single bond. Here it is a carbon-carbon double bond, here it is a carbon-carbon single bond, here low bond length, here high bond length. Hence bond length increases. This here it's a sp2 hybridization becomes sp3 hybridization here. In ethylene complex, in the second complex, there will also be an p pi d pi back bonding. P pi d pi back bonding occurs, but this p pi d pi back bonding is less when compared to the complex one. Here the carbon-carbon bond length will not be affected much more, because it is not an electron withdrawing group. Hydrogen is not an electron withdrawing group. Hence, carbon-carbon bond length is same in both 1 and 2. No, it is wrong, because it is a fluorine electron withdrawing group. Carbon-carbon bond length in 2 is smaller than 1. Yes, it is correct, because in 2, complex 2, the bond length is smaller, whereas in 1 the bond length is longer. The elongation of bond occurs in 1. In carbon, bond length 1 is smaller. It's just opposite. It is all wrong. Olefin coordinates PT in N11. No. Option B is correct. In option 1, that is for complex 1, elongation of bond occurs. C double bond C becomes C single bond C. Question number 8. X-band EPR spectrum of C2OH, CH2OH radical shows dashed lines. Let us take this radical. CH2OH is a radical. In this radical, there are two types of hydrogen, CH2 and OH. There are two types of radical. So, 2Ni plus 1, 2Mi plus 1. Formula. For this radical, it's a 2 into N is 2 hydrogen. I, for hydrogen, I is of plus 1. And for this second one, 2M, there is one hydrogen. Magnetic moment I equal to of plus 1, which is, so it is 2 plus 1, 3 into 1 plus 1, 2. 3 into 2, 6 lines, which shows 6 lines. Option A is correct. Question number 9. The N-type semiconductor among the following. In N-type semiconductor, listen, in N-type semiconductor, it's a valence band, it's a conduction band. Due to donor atom, the donor band is near to conduction band. Due to donor atom, here oxygen is a donor atom and sulfur is a donor atom. Hence, Fe2O3, FeO and Fes is a donor atom, and this 3 is a N-type semiconductor, and Cu2O is a P-type semiconductor, and here option A is correct. Oxygen molecule binds as an hydroperoxide ligand to the metal ion in. Hydroperoxide means it is HO2 minus. It's called hydroperoxide ligand. In oxyhemoglobin, this HO2 was absent. oxyhemocyanin was also there is no hydroperoxide ligand. We find this oxy ligand is in heme3. Oxymyoglobin is also absent. Option C is correct. We will see how it is. Here in oxyheme3 there is 2 ion bridged with the cysteine, which has 3 cysteine bond. Here is bonded with oxygen. Again this bonded with oxygen and another one oxygen, and here you will have one hydrogen, and there will be an hydrogen bond is formed between hydrogen and oxygen. Here you will have HO2 bond, peroxo bond, HO2 minus bond, and here the oxidation state is 3, Fe3. So option C is correct. Question number 11. The spin state and oxidation state of ion Fe in deoxyhemethrin and oxyhemethrin respectively. You see, Fe2 plus in oxy is, it will give Fe3 plus HO2 minus. This is oxyhemethrin. This is a deoxyhemethrin. What they are asking is deoxyhemethrin and oxyhemethrin, what will be the state? Here it is Fe2 plus. It is high spin complex. High spin complex with a paramagnetic. It's a high spin complex which has 3d6 electron. Here it is a 3d5 electron, which is a low spin complex, which is a diamagnetic. Hence here high spin ion 2 and high spin ion 3. No, it is wrong. Low spin ion 2. No. High spin ion 2 and low spin ion 3. Option C is correct. In deoxy it is a high spin paramagnetic ion 2. Oxidation is 2 plus. Here it is 3 plus. Option D is also wrong. Option C is correct. High spin state with 2 plus in deoxyhemethrin and low spin state of ion 3 plus in oxyhemethrin. Question number 12. In Ziegler-Natta catalyst, you see TiCl3 plus Al Pt thrice, which gives a Ziegler-Natta catalyst. Here the titanium acts as a Lewis acid. Titanium acts as a Lewis acid, is an electron pair acceptor. Hence option C is correct. Here the 1,2 insertion occurs. Hence it is a Lewis acid. Question number 13. The correct order of RHC bond length in the complex. 3 complex has been given. What is the bond length that they are asking? Let us take the complex. The first complex, in first option, you have RH, CO, PPH3, Cl. In option 2, in option 3. Now listen, in this 3 complex, what happens here is, in PPH3 is an electron withdrawing group. It's an electron withdrawing group. Here also it is an electron withdrawing group. Here you have, it is an electron donating group. It's an electron donating group. In this complex, second complex, due to electron donating group, it donates all the electron to RH. As a result, as a electron donating, as a result, the bond length of RH and C, here this bond length decreases. Here you see, here it is a electron withdrawing group. It withdraws the electron, hence here the CRH bond, this bond length increases. And in option 3, it is more electron withdrawing group, and here the CRH bond length is greater than option 1. Here it's a more back bonding. Hence this RH C bond is greater in 3 than 1 than 2. Hence option here 3, 1, 2. Option B is correct. Question number 14. The point group of phosphorus pentafluoride. Here phosphorus pentafluoride, which shows sp3 and D3 hybridization, sp3 D2 hybridization, which is a trigonal bipyramidal structure. Which is a trigonal bipyramidal structure. They are asking the point group. Here it contains the C3 axis. Here is a C3 axis, and it contains three C2 axis. It contains 3 C2 axis, and this 3 C2 axis is perpendicular to this C3 axis. Hence it shows D3 H, where the magnetic moment is 0. It shows a D3H point group. Option C is correct. Question number 15. Which among the following beryllium alkyl compound are stable? T-butyl. It's wrongly printed. It's a T-butyl. So this complex is B T-butyl twice. Here this compound is BCH2 T-butyl twice. Here, to be a stable compound, the compound should get dimerized. In option 1, this compound will dimerize like this: BME here it is Me. So it shows a 3 center 2 electron bond. Is more stable. Is more stable because it forms dimer. And this compound too, similar. It's a ET BE. It is also forms a dimer ET beryllium ET. It's also stable. Whereas in compound 3 and 4, T-butyl is a bulky group but do not form dimer. It will not form a dimer. So it is less stable. Compound 3 and 4 are less stable. Hence here they are asking the stable compound. Hence here 1 and 2, option D is correct. 1 and 2 forms a stable compound. 3 and 4 is a very less stable and do not form dimer. We will meet in the next video, part 2. Thank you for watching. Thank you.